This, we cloned university data example at the previous lesson. I made minor changes, and I also added branches from newer version of the code from the author. Author is the author of tutorial, Mary Ellen Bowman. She's the author of the code. I just copy-pasted this code. It's not my code. So a quick reminder: in week 1, there is a link to course resources, and there is a tutorial, Spring Data, Mary Ellen Bowman. When you go to this tutorial, it will take you to Linked Learning. In the Linked Learning, you will see that it takes several chapters. This tutorial is based on previous year tutorial, and code that I will explain today, it's kind of merged between two. A previous version of her tutorial contains about the same code, but testing is simpler. So her testing code is simpler. And she also added 2 additional chapters, not 2, I think 2 additional topics that I'm not covering. At least at this moment. So when you open the code, clone the code, if you clone this separately, previously, probably you did it at the previous lesson, fetch changes, and after fetching changes and closing this menu and opening this again, this one, you will see chapter 1, chapter 2, chapter 3 branches. It's almost the same, except it has more tests. It is, I already mentioned that she has 2 versions of it, previous version and new. New version came up just in I believe it is December or January this year. So it is right in front of the course starting. It is the same code with more tests, plus she has additional topics in the end. So I inserted chapter 1, chapter 2, chapter 3. Because of more tests, so we can look at that. In chapter 4, I will also insert chapter 4, and it will be end of it. I will not cover topics after chapter 4. Chapter 4, it is, you see, chapter 5. She is talking like a RESTful service, which will be covered which is covered separately. But it is not a lot, it's 9 minutes only. And after this, she's talking about NoSQL databases, which is not part of it, part of the course. Okay. This is not also part of the course, so I'm skipping chapter 5 from her tutorial. Okay. Questions? So let's look. I will quickly remind what I started to explain, because in the previous lesson I spent only about 10 minutes to explain it. So I will quickly remind what is going on. So currently I'm looking at main branch and not testing cases. So let's remind what is in the code. This is her structure of this project. I just copy-pasted into newly created project because she was using Maven and Poe, and this is using Gradle. So, and this is using Spring Boot 3, so I had to change some of the code. Not a lot, just some. So let's look at entities. When we look at the names, it appears like we are using inheritance. We have a person and staff. Obviously, staff member is a person. Student also is a person. It appears like we use inheritance between these classes. It is not the case. It's imitation of inheritance. Why did she do it? Perhaps to demonstrate that it's possible to do it this way. Today we will cover another example where inheritance is actually inheritance, where we have one item is inheriting from another, one entity is inheriting from another entity. So it is possible to implement inheritance with actual inheritance, not with this one. What does she do? She is using composition. Although logically there is a relationship between these classes is clear inheritance because a student entity is inheriting from person entity logically, but she is using composition. It is carrying the same data, essentially, right? If we include person object into student object, it will contain the same data. It is probably less clean approach, but it will potentially work. So composition, what is composition? Composition involves like ownership. So it is, if we compose person into a student, if we take person and put it into as data inside of the student, like it will appear like student is owning some person with first name and last name, which is not the case. But from programming point of view, why not? It carries the same data. So that was the approach. So let's see how it works. When we open person, it is marked with embeddable, not entity. And embeddable means this object will be part of another object. And data from these objects, like marked with columns, will be columns inside of another table. We have a table student, and we embedded person inside of student, and this data will be just extra 2 columns in student table. So this is what was her approach in order to implement inheritance. So she used composition in order to implement something similar to inheritance. Right. So what else is in person? We have 2 columns, first name, last name, and constructor, and setters and getters, right? No, nothing special. Columns are not marked with names explicitly, and there is a reason for it, because she doesn't have to. Why she doesn't have to? Because she is not creating tables using SQL code, but tables are generated from entities. If tables are generated from entities, column names will be compatible to entity names by default. Names inside of entities by default. It looks like it's a little bit sloppy approach, and it's not just looking like it is a little bit sloppy approach, because we would have to guess what would be name of the column based on convention, but if we write column name explicitly, we won't have to think about it. It will be explicitly set. Since she is not setting column names explicitly, some of her other code is also shorter. For example, for many-to-many mapping. Actually, for any mapping, not just many-to-many, but many-to-one. Because when you do like many-to-one, one-to-many, many-to-many, you need to specify which column is foreign key. Which column of the table is foreign key. And for many-to-many mapping, you will also need to specify if database is already existing, which table is used for mapping itself, right? For many-to-many, we need to create special table. If a database is generated automatically based on the set of entities, it will be generated compatible way, so we don't have to worry about mapping connections. Like which part is marking, which part of the code is talking to specific column and table. So for this reason, her code is a little bit shorter. And second example for today, it has all of it specifically defined. So we don't have to, so we have a shorter version and longer version. So let's look further. Stuff contains embedded data for the person. And the rest, it is kind of default, right? ID, nothing else. A student table contains also embedded person, also column of Boolean full-time, part-time flag, age, because some of her queries is related to age, like select 20 years old students or students less than 19 years old. So this kind of queries that we will cover. And also there is a relation between student and courses registered by the student, or to the student. So let's talk about this one. In the relationship between student and courses, it is one on side of student and many on side of courses. What is fetch type eager? Fetch type eager works this way. When you retrieve student by API call, student entity object by API call, it will also retrieve this list of courses associated with the student in the same API call, your API call. Under the hood, it will be more than one API call because it needs to query table of students, table of courses connected, right? But if you specify it as fetch type eager, you will receive student object with already linked courses to it. It is not the default behavior. Default behavior is different. Default behavior, it is fetch type lazy. It means when you ask for student entity object, it will give it to you, but list of courses is not linked yet. When would it do this query and link it? It will be right before place in your code when you access this variable courses. Okay? So it will not do this query, database query, unless you have part of your code that is accessing list of courses associated with the student. So it is optimization, definitely, but it will make it fast in some cases, slower in some other cases. So it really depends what you need. So why did she put eager? Just to show that you can do it not default way. In default way, it is on as needed basis. It will provide this link on as needed basis. It will do query for the courses only if your code contains some code accessing this variable. So this is the meaning of eager. What is cascade? Cascade is behavior, what happens when you do operation on entity. For example, if you save student object, you may want to save association with courses, like links to the courses, because you added one course, because you registered the student to another course. You want to save association with it. Or you may want to save data about course if you already edited the course in your code. So it's different behavior, right? When you delete student, you definitely don't want to delete courses associated with the student, right? So it really depends on your logic of your program, right? Why it is cascade all? I think because she was a little sloppy. This is why it is cascade all. Cascade all means propagate all updates, like you save student, it will save this. But what if you want to delete students? It appears like delete should propagate, right? Because it is cascade all. Propagate operations done for this object to linked objects. Is it right? I think it's a bug or just a little sloppy. The best way is to test it directly or just look up. So I wouldn't bet money on it that this is right. Okay. So I will try it, or I will try it, and I will tell you before the next lesson if this part is right. It looks suspicious. So cascade means propagation of operation from this object to other object. Okay? Save looks reasonable, but delete probably not, because we don't want delete courses when we delete student from database, right? So it is probably a little sloppy. Not a little, but sloppy. But let's check it and put it on hold till next lesson, this part. What I noticed that she's always writing eager and cascade type all, probably because she's explaining other things and don't worry about this stuff, these pieces. So this is about student, and it is one-to-many. This is relationship from one side, from student to courses. When you code relationship inside of entities, you may create a link backwards. For example, link in course, that is a list of students registered for the course. This will also work if you create it, but you don't have to. In GPA, when you code relationship, you are required to code it one way, and you code this in opposite way only if you're going to use this feature. So if you if you are not going to use the feature like list students registered from the course entity itself, you don't need to code it. And she didn't. So when we open course, we don't see a list of students. So it is optional, we can create it, and it will be populated when you retrieve course. When you code relationship backwards, it's not symmetric in general. One of the reasons, because if it is one-to-many, it's one side, it is one-to-many, and opposite it's many-to-one. So it's not symmetric by definition. But even if it is many-to-many, which looks kind of symmetric, it's still not symmetric. Because in one way it is required, and opposite way it is just telling the system that you need the opposite link. So it provides less information because first link provides more. Okay? So we will see it on example one-to-many and many-to-one here. So what do we have here? We have many-to-many relationship to itself, to the course, to the list of prerequisites. So also this is a little suspicious cascade. When you delete course, it shouldn't kill prerequisites, right? So this is on hold till next lesson. Okay. Fetch type, this may be necessary, fetch type all, if your query needs to connect courses and prerequisites together. If it is not connecting courses and prerequisites, you don't need to preload it ahead of the time. She discussed this explicitly in her tutorial. Like if you have a query that is connecting the list with data inside of the object, like here, if list is not preloaded with eager, it will produce exceptions. So maybe this is the reason why she's writing eager everywhere, to avoid this kind of things. Okay. But these exceptions happens only if you access two pieces at the same time inside of queries. Right? So what else is inside of the course? Course name, number of credits, and relationship to instructor. And this is definitely simplification. In the universe of this example, instructor can teach only one course, which is not in the reality, right? So it is not real situation, it's just imitation. And it is definitely imitation because in reality, we also have sections per courses, right? So, in this case, it associates student with course, but not with section, right? So in reality, it would be also sections, right? So reality is slightly more complicated. So it's a demo, essentially. Okay, so next, course is associated with department. And if we look inside of the course, can we find department? Yes. And association is many-to-one, right? many to one on this side. And when we go to department, we will see it will be list of courses, but it also will provide reference to this variable name. So it will be linked in opposite direction. So it's not the same. It's simpler on one side and more complicated on the opposite side. So let's go to department. In the department, as already mentioned, it's one-to-many, and it provides fetch and cascade type all. Cascade type all makes a lot of sense if we have ownership. Like you have book titles versus chapter titles. You have some table for book with titles and another table for chapters related to books. If you delete book, you may need to delete probably chapters, data about chapters of the book, something like that. So when we have ownership of one item by another item, it is definitely cascade all. Because this way, if you save one, it should save dependent items. This is certainly true for when it is ordered. So if we consider that courses are owned by the department, it is correct. Because and the probably assumption is that if department is kind of reorganized, these courses will be moved to another department before you delete department, something like that. So this looks correct. All right. Then a relationship to chair, one-to-one, department chair is one, and type of the department chair is staff. Next. And I think this is it. We already covered relationship. So what about repositories? Some repositories are just default, some of not. For example, course repository contains queries. It also contains queries encoded inside of name of the methods, like we already saw before. A department repository is just default in this case. Staff repository is default. Student repository contains, in this case, contains queries encoded in the name of this, in the name of the methods. So let's start with this one because it's easier. Student repository. I skip default because there's nothing in it. It's default. So for today, for the first half of the lesson, today I will explain, not first half, yeah, kind of. First task for today, I will explain student repository and course repository, and also we will have some testing cases because testing cases contain information how to retrieve data by pages, which is also a very useful feature because when we have items like listed, like if I put class role, it will show me by pages, right? It will not list everything. So this example also contains information for paging and sorting and query by example. So let's do it step by step. So if we want to find records by matching field name, like list full-time students, it's easy to find by and property name. In GPA, GPA always refers to class names and property names, and it never refers to table names and column names. So if we see like full-time, this is property. It's not a column. Unless it is query explicitly written in, explicitly referring to native SQL. It is possible to write query referring to native SQL. It is not covered here, it is covered in chapter 3. If you switch, it will be there. So the same for age, find by age and age. This is also by property, but in this case, it is property inside of property. Find by, because we're looking for, attendee, it's a property inside of student. So student contains property attendee, who is a person. Right? And attendee property is containing full name. Oh, not full name, first name and last name, right? Two properties. So inside of student repository, I have attendee last name. So we chained properties. This is object inside of student, and this object contains last name. All right. Now she is showing how to combine queries. For example, find by first name and last name. This is good candidate to create SQL, right? Or not SQL, but a query line, because this name is quite long. Right? So find by, again, attendee, first name, and we can combine it with and or expressions. And attendee last name. We can provide it by object, so it will pick data from the object and look for it. We can also put expressions with comparison, like greater than, less than, like find age less than, and given one, so anybody younger than this age. We can provide extra information for the search, like ignore case for this last name. We can do searches by similarity, like, SQL kind of like. So provide pattern, like substring, what we're looking for. We can specify sorting, like ascending, descending. We can specify that we want only first one, or like several in the beginning. Several in the beginning will be like top 3 in this case, first 3. Right? Okay. Find top without number, it is first. So find top by order by age descending. Right? So it will be find all the student, right? Correct? Find all the student. So find top by order by age descending. Okay. Where to find information on grammar of it? It's Google. Spring data, I will show. Just Google Spring data. Spring data. And it will come up Spring data GPA. And it is repository query keywords. Here it is. Find by, it is only one of the options. Other options also for exist, for counting, for deleting. You can also specify that you want only distinct queries. Connecting conditions, so it's a summary. Okay. There are also books written about it, specifically on Spring data. Links to books. Also, if you need to go into depth later on for some reason. So here it is, Spring data. Yes, beginning of Spring data, here it is, published this year. So let's continue. As you notice that sometimes query written in the keywords inside use it as part of the method call are quite complicated. In this case, it is quite long. So the good candidate is to replace it with something else to provide information elsewhere. So we can provide information on top of the method is query to make name more convenient. Okay. So the example for it is course repository. Here it is. In the course repository, find by name is short enough, so why not? But if we need to do something fancier, like find a list of courses, if you don't know department, but you know last name of department chair. This is definitely quite fancy query, right? And if we try to code it inside as a name, it will be a quite long name. So find by, in course, there is reference to department. In department, there is reference to chair. Chair itself is staff. Okay. Okay, let's go through structure of it. Otherwise it's not clear. So course has different reference to department. Here it is department. Department has reference to chair, right? So it is department chair, but this is staff. Staff has reference to member, and member is the person. Person has reference to last name. Okay. So in order to make a query, we collect all this chain. So we will have in course repository find by department referring to chair. Chair has a field member. Member has a field last name. Okay. What if we want to have it shorter? We can find by chair last name, but this name does not contain all the information, so we need to provide this information separately. So this information is provided in JPQL language, Java Persistence Query Language. It looks like SQL, but it's not, because you see that it is referring to class names, not table names. And it contains like a variable declaration next to the class name. So select C, this is variable, from, it is declared here to mimic SQL. And variables contain properties, and those properties are from classes, not column names. We can have parameters, and if parameter doesn't match variable name, we need to specify name of the parameter next to the variable. If it is the same, we don't need to insert this part. So find course from course, where course, department, chair, member, last name, the same chain as you already saw, equal to chair last name. Okay. Or find course by prerequisites. In this case, we have a join, like SQL inner join. Where course prerequisites, P, this will be prerequisites, where prerequisite ID is equal to this ID. So she is showing how to refer to numbered parameter. So we can name it, or we can use number instead of it. If it is one, we can use just one, or if two, and so on. Next example is showing that we can create views. A view, it is a reference to a table derived by query, the same as SQL. In this case, view, it is just regular class, course view, that contains 1, 2, 3 fields. Course name, last name of chair, and last name of, not chair, instructor, right? Course refers to instructor is a member is last name. Right? Member has last name. So this course view contains 3 data fields. So course view, name, instructor, last name, and department name. Okay. So course repository, we can create object that is returned here as a view. So keyword is new. Unfortunately, we cannot refer to class name by shorter name. It is fully qualified class name with all these package names in it. Okay. So this is selection by course ID. where course ID is equal to provided ID. Find by credits, no query on top because it is short. Find by credits, no query on top. But this will be used in testing to provide paging information. So we can split output into pages. So this will retrieve specific page. Okay? Which page is specified inside of Pageable? Specification is page number and length of the page. So it knows how many, so it will count. And last one, this is also by name. Department contains name, so it is find by department name. And last one, it is what it is, get course U by name, right? So we look for name equal to provided name. And it is returning course U, so it is creating a new object by calling constructor of it with these parameters. And now let's look at the test, because test provides more information. One piece of extra information, it is how to deal with retrieving data by pages. And second, how to do query by example. So in this example, we have all tests in one file. Unlike in newer version of this tutorial, in newer version, she did more work in terms of organization. She split this into several files, and all those tests also contained like testing parameters. In this case, it is just making outputs into println into console. So we will look at the output and judge if it is right or wrong. There is no comparison. Unlike in chapter test, it is newer version of the tutorial. If we like switch, for example, to chapter 3, checkout, we will see that there are tests are separated into several files. When we open it, we will see also that there is assert true, and assertions. Right? In another test, it will be other assertion, assert equals. So it is more elaborate. Okay. Regarding your assignment, go with the simplest. Do fancy tests if you have time left. So for your assignment, do it like in main. Just print out stuff what you're doing, what was before, now what is after, so you know that it's doing right. So I switch it back to main. So let's look inside of the tests. So from the top, she starts with simple query examples by calling methods where information is inside of the name, method name. Like student repository, find age by 20. Where this student repository is coming from? She's using field injection. Field injection is a good idea only inside of tests. Otherwise, it's not. Because when we use field injection, this field is not accessible from outside of the class. We cannot really assign it. We cannot write tests for it. We don't write tests for tests classes itself. For this reason, it's fine inside of tests. For other reasons, field injection is not recommended. It's only for tests. Best option, it is constructor injection or setter injection. So setter injection, you write setter method with outer white on top. So those repositories are injected into fields with marked outer white. So and now student repository find by age 20. For each applies println statement to the iteratable list, so it will print those items. So this is how she is doing find full-time students, then find by last name provided door. Okay. So let's run this test and see what it is doing. So I run with this method separately. It takes time to start. Here it is. So find students by age 20, found 2 students. Oh, 1. This is already full-time students. It's not all full-time students. Found 3 full-time students. So it looks believable, right? So let's continue. And now, using query, the same approach is calling method and println after string on return type. So these tests do not provide extra information except that it works. So when we run it, it's not crashing. It's producing something that looks believable, so it's working. Extra information comes here when we have, not even here, when we have queries that contains paging. So I'm explaining paging and sorting queries. First, she is calling find by credit 3, and it is producing list of courses with credit 3. So it comes from repository, course repository, find by credit 3. But there is another method where we ask it for parameter, to use parameter pageable. So this is extra information, so let's see how to use it. Okay. We provide second parameter. Okay. A course, find courses by 3, and second parameter, page request of, page number, length of the page, sort direction, and by which field. First by credit, second by name of the course. So relatively straightforward. Right? We can use pageable not just with the methods where we declare it, we can also use it with system provided methods like find all. So in this case, sorting can be enclosed into separate object. So this is what they have. Sort by name, and this is object created to specify sorting. Sort direction, and by what? Member last name. And she's calling staff repository find all with the sorting. So this is not limited to paging. And we can do the same with paging. Find all, page request of, and sorting object. Right? So this is probably the most useful part out of it. Not the most, one of the useful items to learn. Also, query by example. When we do query by example, we create objects with specified fields that are important, and not important parts are just set to null. So system will find objects that match specified fields. Why it's necessary? Because it is dynamic, right? Kind of dynamic. You can generate this object in your code. So query by example. How to do it? You call system method like find one or find all, and create example of in the object that you're looking for. What is specified is important, it will be matched. What is null, it won't be matched. So in this case, we are looking for department named humanities. Example of department named humanities. What it is this one? Find departments with the first name of the chair is John. Right? So we're creating department. Name of department is not important, so it's null. Creating staff member that takes person as a parameter, and for the person, last name is not important, so it's null. First name is John. Right? So this will look for departments where department chairs, first name is John. Also cool idea how to create this query. I love it. When we do query by example, we can provide extra information. In the previous lesson, I explained an example university data demo that came from video tutorial posted on LinkedIn Learning. This video is available for free because you're students, so you can watch it. Unfortunately, it contained some mistakes in the code, not explicitly discussed by the teacher. This is why it was missed. And because her examples are not explicitly related to this code. But since this code is posted, we need to correct it. So you know that it's a mistake, so you don't repeat it. So where is the mistake? In student table, there is a link between students and courses where this given student is registered. So in the previous lesson, in the previous section, when I taught this lesson on Wednesday, some thoughtful student asked a question. And I thought about, yeah, indeed, it's a mistake. And I checked it explicitly, yeah, it is a mistake. This line, this piece of code contains two mistakes here. So, what are the mistakes? Our first mistake is link between student and courses. One too many, so this is wrong. One is side of student, many it is side of courses. Many is correct because one student can register for many courses. But one is wrong. It means one course capacity is only one student. Okay? So if it is one too many, you cannot register more than one student per course, because at the time of the same student, it will cause crash. Okay? It will throw exception because it's relationship and the way how it is implemented, you cannot, if it is this way, you cannot register more than one student per course. So this is kind of obvious, but it wasn't obvious because I didn't notice, but one thoughtful student noticed this in class. This is definitely wrong. It's not one to many, it is many to many relationship. Okay. Second mistake, that it wasn't that obvious, but it was also noticed. It is cascade type all. This is also wrong. But reason is different, obviously, because it's different mistake. What is wrong about it? Cascade means propagate operation from given object to the linked objects. If you say all, it will propagate all operations, including delete. So it literally means if you delete one student from the database, it will also delete all courses from the database where the student is registered, which is definitely wrong. And I checked this explicitly. I created an example with created fake students, created fake courses, registered student to fake courses, deleted student, it deleted the courses. So this is definitely wrong. Cascade type all is wrong. So what it's supposed to be, what kind of cascade? We can be more specific which to cascade. Not all, but what are specific operations. Save operation, but save, it comes in two flavors. Save as a new piece or save as updated piece, so it's two different. A save as a new piece, it is persist. Save as updated piece, it is merge. But that updated piece also includes new. So merge, it's both, actually, as a new and as updated. It can also delete, and the list can be comma separated, so it doesn't have to be one. It could be several things. In this, which one applies here? None of them. Because when you edit data about student, like you retrieve a data about student, you may change items in this list. But why would you edit data about specific course at this moment? Logically, it's not what we would typically do in this scenario when we edit student. Imagine you retrieve a student from the database. You may add list course, you may remove course, but you will not edit course table, right? If you want to edit course table, you'll probably request course separately, right, from the database and edit that course and save it. Right? But what would save this list without editing course table? So it will maintain only association. It is done by default. So in this case, none. Correct answer is none. Because if we edit student, like with changing names or adding course, removing course from the list, a registration will be updated by default. So we don't need to add anything. So correct answer, remove it. Incorrect answer, also change it to many. Okay? So we can, in today's example, we will see options. Why it is fetch type eager? The author of this code probably wanted to show that you can do something which is not default. Default is not eager, default is lazy. How lazy behaves? When you retrieve student, it doesn't retrieve the list immediately. It will retrieve the list at the point in your code when you access this variable courses. And if you don't access this variable, it will not retrieve it from the database. So it is optimization. So it means if you delete this one, it will be also right. It will be just a different approach of retrieving the data. Okay. So I would keep it even like that. Any questions? Yes?
What was the default cascade mode again? Like you said, it could do the default, but is the default to just like not cascade at all?
Yes, do not propagate saving operations, but what it will save definitely association by default. So if you add course, it will register student to the course, like it will create a link. It will be done by default. But if you edit any course inside of the list, like change the name of the course, it will not save it into database. But the real question is, why would you want to edit course when you edit student? It's totally different task. In my opinion, it's unlikely to happen in your code that you edit course at the same time when you edit student. It should be like separate piece in your code. You retrieve course, you edit it, and you save course. You don't save it with the list of students, as a list of one associated with specific student. Okay. So I would say many to many without anything, it is the best choice. Another thing that is also related to this cascade issue, it is in course. Somehow, it is also here. It means if you delete course, it will try to delete prerequisites of this course, which it doesn't make sense. Because it will cascade given course object into prerequisites also. Right? And cascade all makes a lot of sense if we have ownership. Like you have an association between art pieces and artists in your database. If you delete artists, maybe for consistency, you want to get rid of art pieces as well. So if there is some ownership association, cascade all makes sense. Or we have database between pet owners and pets. You delete pet owner, and associate pets are linked to pet owner, so probably it makes sense to remove pets as well. So cascade all, it is for ownership, definitely association, or something that makes sense as ownership. Not exactly ownership, but kind of behaves the same way. So this is also a mistake. Okay. And eager, it is showing how that by default, it will retrieve a list of prerequisites at the same time with retrieving course. Right? So it really depends on your queries. If you query a lot, like association between courses, you need to do that. If you do query with association of courses like this, you need to do it. And if you almost never look up for prerequisites, you can put it like by default as well. And this is many-to-many. This is right. Questions? No? So this is a correction. And I tested this explicitly by just, okay. I created a project from scratch with course and student, with 2 tables, just to make sure that I'm telling what is right. So it's not, I tested this as it is. So created data initializer. I created 4 fake students, Bart, Lisa, March, Homer. Created 4 courses. It is your first year courses. Then I registered Bart and Lisa to some courses, and March and Homer, they are not registered. So course repository is safe. So these are courses. I go to repository, right? So these students courses, saving students, student repository save, saving courses. After this, I created register to course for a student. Register to course for a student is, I have a list of courses the same way, many-to-many, so it is after debugging, I'm sure it is many-to-many now. I have a list of courses, and register to course, it is just add course to the list of students in a list of courses associated with the student. And after this, I'm saving student. Why do I show this to you? Because this part, it's not immediately obvious. So you know about it. Yesterday, when I was writing this, I spent more than an hour to figure out what is wrong with it. Okay? So please pay attention to this one. This is not obvious. A registration is kind of obvious. You add course to the list, you save student, it will save association. So it is kind of obvious, right? Removing is not. Why it is not? When you unregister, obviously you need to take courses and remove. Right? Do some remove. But you cannot remove this course because it's different object. Unfortunately, when you save the course, you're creating duplication of the object. So when you save courses, you can save students. When this object goes to database, it creates duplications of objects. So when you if you try to remove this object explicitly from the list, it won't remove because it's different object. It will contain the same data, but it's different object. Right? So in order to do that, instead of remove, it is remove if course contains code, it is ID. If code of this course, what I'm about to remove, is matching code of this course. Okay. So I'm deleting when ID is matching, not deleting given object. If you try to delete given object, it won't delete because it's potentially different copy of the object. It's not the same object. Okay? Because when you save objects to database, it's creating copies. And it keeps somewhere in memory, so when you pull it out, it could be different copy. It doesn't have to be the same object. All right? And if remove from the list doesn't work, saving will not remove it from the database because it's still in the list. Right? Okay? This is shortcut for the loop. You can go through the list using loop. You can do if ID is matching, you delete that object. If ID is matching. Yeah, I did it with the loop first, and IDE told me You can do it quicker. And I said, OK, do it quicker. And it created this code for me. I didn't make this code. This is optimization from IDE. I did it brute force through going through the loop. Like, found the object with the same ID, delete that object. Okay. Again, and IDE said me, yeah, it's not so smart. You can do it quicker. Okay. Questions? So I didn't pull this code because it doesn't do anything super smart. It is just brute force. So in data initializer, I had, when it was delete Lisa, and after this save Lisa. When it was wrong association with cascade all, it was indeed removing 2 courses from database. I checked it. So it was indeed wrong. By brute force check, I know. Okay, questions?